Let us see on how we can make use of the roots or the solutions of the quadratic equations. What are the roots and what are the solutions of the quadratic equations? And for instance, let's say we have the quadratic equation given as x squared, and let's say plus x minus 6, and I say is equal to 0. Let's say this is the case. So now how can we be able to solve for x? And in this case, we can be able to use the factor method in the sense that we have it as x squared and plus 3x, that is minus 2x, and minus 6, that is equal to 0. And we'll have it as x, and the x plus 3, that is x plus 3, and I'll have minus 2 and x plus 3 as well. That would be equal to 0. Now we'll have it as x plus 3, and that is times x minus 2. And I'll have it as equal to 0. So now we'll have it as x is equal to negative 3, and also x is equal to, and that should be 2. Now these are said to be the solutions. They are said to be the solutions of the quadratic equation that we have, and also they are said to be the roots of the actual equation. They are said to be the real roots of the equation. And I'm not saying these are the solutions of the actual quadratic equation. That on the same case, they are also said to be the real roots to the actual equation. In other words, they are said to be the roots. Now, x is given as negative 3, and also x is given as the positive 2. These are said to be the actually real roots, or the roots of the quadratic equation, and also they're said to be the solutions for the quadratic equation that we have it here. In the sense that, let's think of actually writing this one to be given as, let's say, a root 1. So root 1, it is the same as x negative 3, and let's say a root 2, it is given as, let's say, x positive 2. Now let's think of substituting the root 1 as well as the root 2 into the equation and see how it will behave. Let's say we have root 1 to the power 2 and plus, let's say, a root 1 minus 6 is equal to 0. Will it be is equal to 0? We should have to see if whatever will have this side to be the same as this side. We should have to see. Now, what is the root 1? Negative, actually 3. And to the power 2, we have it as the positive 9. And we'll have that. Then, what is root 1? Negative 3. In the substituting here, we'll have it as minus 3, minus 6. And you see that this is a 6 and also minus 6. In this case, we'll have it as 0 is equal to 0. Hence, x minus 3 is said to be, now x minus 3, it is said to be the solution or the real root of the actually quadratic equation, since it can be checked. Since what we have this side, it is the same as what we have this side. It means x minus 3, it is the real solution and for the equation. And also let's do the same with the other actually. And also let's do the same with the other actually root. Let's say we have root 2 to the power 2 and plus x. Now should be plus root 2. Now should be plus root 2 minus 6 is equal to 0. What is root 2? We have it as actually 2. Into the power 2 we have it as 4. And the plus 2 minus 6. You see that at the end of the day we have it as 0 is equal to 0. Hence x actually is equal to 2. It is also said to be the little root of the actual equation. Since upon substituting that one, what we have the other side, it is the same as what we have the other side. So which means the solutions that we obtained from the quadratic actual equation, they are always true for the quadratic equation, in such that if we substitute them back, or actually give us the equivalent, in the sense that if we in the sense that what we have to the right hand side, it is the same as what we have on the left hand side. So that simply means that the solutions that we have are the real actual solutions, or the real roots, and for that particular quadratic actually equation. Let's say we have this case. Let's have x squared and plus 3x should be plus, let's say, 12x and plus 36, and let me have it in this way. Let's say is equal to minus 36. Let's say this is the case. So identify the solutions, or the little roots, and for this equation, and actually show whether they are little roots or really they are the solutions for this equation. You know, it is the same as solving for actually x here, but we would like to see whether those values of x will really satisfy the equation or not. So which means we have it as x squared plus 12x and plus 36 is equal to 0. And what will go up next, we'll be able to solve for x using the factor method. So which means we'll have it as x squared and plus 6x and also plus 6x as well, plus 6x as well, and plus 36, that will be equal to 0. In this case we have it as x plus 6, and we have it as 6 and x plus 6, and which is equal to 0. Then we have x plus 6 and times x plus 6. That should be that x plus 6 as well. That will be equal to 0. So in this case we have x is equal to negative 6 and also x is equal to negative 6. So let's see if those are the solutions and for the equation. Now you see that upon substituting those values, at the end of the day we'll have, at the end of the day, those solutions will be true. Let's think of substituting actually in negative 6 here and also here as well. So in this case we'll have it as 36, we'll have it as 36, and then we'll have 12 times negative 6 will also be equal to negative 36 as well. What is 12 times negative 6? So we have it as 36 and minus 72, and this is really equal to 36. So which means actually x negative actually 6, they are the real solutions and for the actually equation. Hence they are also said to be the little roots and for the equations. Now, using the concept of the actual little solutions or the little roots and for the quadratic equation, let's think of having this case. Let's say we have the quadratic equation given as, let's say, m, let's say we should have it in this case. We have, let's say, mx squared and minus 2x plus 1 is equal to 0. Now, assuming that x, I should have in this case, assuming that x is equal to 1 is the solution or is the root for this actually equation, find the value of actually m. Assuming that x is equal to 1, it is the root, and for this actual equation, find the value of actually m. So now, which means if actually 1 is said to be the solution for this problem, it means even if we substitute whatever we have this side, it will be the same as that side. So it means it is true solution for all. So just have to substitute for x. That will be given as m minus 2 plus 1 is equal to 0. That will be given as m, and that should be minus 1 is equal to 0. Hence m will be given as positive 1. That is the solution for m in that case. And let's say we have the equation given as k x squared minus, let's say, 2k plus should be 2kx is equal to, let's say, a 4. Now, assuming that x is equal to, let's say, 2 is the solution, or it is the root of this actually quadratic equation, find the value of k. So now we should have to solve for the value of k. Now, how should you go about it? So the principle remains the same. We just have to substitute the x, and therefore actually we'll just have to substitute for x. That will be given as, now have it as 4k, and the minus, and that will be given as, now we'll just have to substitute here for x. That will be given as, rather we should have a positive here, then we'll have it as a 4k as well. That will be equal to 4. Now these are the last terms, we just have it as 8k. That will be given as 4. Hence k will be given as 4 over 8. That is the same as 1 over raised to 2. So this is the value of k in that case. And let's say we have this case. Let's say we have the typical quadratic equation, and that is given as, let's say, kx should be k squared minus, let's say, 4k minus q is equal to, let's say, 0. Now, assuming that k is equal to, let's say, 1, that should be k, let's say, is equal to 12, is the solution, and therefore this is actually a quadratic equation, or it is the root for this quadratic equation. What is the value of actually a q? So try to go for that. And let's say we have, in this case, we have x. Let's say we have x squared, and minus mx, and plus, let's say, 5n is equal to, let's say, 2. Assuming that this is the quadratic equation, and let's say it is having the roots of, let's say, x is equal to, let's say, 1, and also x is equal to 2. Find the values of m as well as the n. So we should have to calculate the values of m, and also the value of n. How should you go about it? Since we have two actually values, that means we'll have also two equations with the non-variables, that is m as well as the n. You solve for that using the actually simultaneous equations. In other words, you have two simultaneous equations, because x is equal to 1 will have its own equation, and also x equal to 2 will have its own equation, and that will register as actually two actual equations. So let me just have to start it up for you. We have it as, now let's think of using the x is equal to 1. So which means if we substitute for x, actually for x as 1 here, we have it as 1 and minus, here we have it as m, and plus 5n, that will be equal to 2. So which means we have it as 5n minus m, that is equal to, now we'll have it as, there should be 1. This is equation number 1. And also let's do the same with the other, actually a load as well, that one. Let's think of substituting for x there, that will be given as 4 and the minus 2m and plus 5n, that will be equal to 2. So now which means we can have it as this, so which means we have it as 5n and the minus 2m, that will be equal to negative 2. We'll have that one as negative 2. And this is given as the equation should be number actually 2. Then you solve for any answers the m using actually simultaneously rather. So try to have that. And also you should have to try this as well. Let's say we have the actually equation given as qx squared and minus d actually x is equal to, let's say, 4. Now assuming that x is equal to, let's say, 5 and also x is equal to, let's say, 10. They are the solutions for actually the equation. Find the values of q as d. So that's how we should have to make use of the loads and the solutions of the quadratic equations. Thank you.